right here, and it's basically a rootkit inside the masterboot record. And Michael Sandler is developing the Trojan part, which is on top of my base, and I'm developing the core of the bootkit, which basically attacks all operating systems and is responsible for loading at the boot and injecting code into the memory, into the running operating system and running beside the operating system, and then loading the payload beside the operating system in full system writes. So it's injecting code into the kernel mode, which is prevented with Windows Vista 64-bit. There you can't load any unsigned driver code anymore. And using my bootkit, you can load any unsigned code into kernel. And then you can basically do everything. You have full access to the whole system, and you can do whatever you want. We are going to introduce you the next version of it, and we are showing you then how it works and the new techniques it has. And what has changed since the last version is now the remote surveillance software. That is the Trojan on top of it. And we will show you a small live demonstration how it works. And on the end, we'll also talk a bit about TPM and how you can defeat it and how it can prevent from attack. I'm Peter Geisner, and I have had some other talks. I've worked 1 year at an antivirus company, and I'm basically doing research in the operating system and in general software. I'm writing everything in assembly language and doing that all at the very low level of the computer. And I'm developing the Stone bootkit now together with Michael Sandel and with newcomer, who developed also the Way bootkit and Way bootkit 2.0, which were famous for first attacking Windows 7 and loading unset code into it. He held also presentations at Black Hat, and I had also a Black Hat talk and some other talks. Unfortunately, I can't show you everything because there's currently a court case running against me. So I do not have my original notebook, and I had to write everything from scratch and all the information here, and can only talk from scratch because they have my original notebook currently in custody, and so I can't show you all features. Previously I announced that I will show that the Stone bootkit would work also for Linux and 64-bit Windows, but I had to stop the development of it, and so I can show you only the intermediate results. But I think it is also going to be interesting because there are lots of things that were new since the last presentation, and I will show you just those things. And yeah, keep in mind it's everything just from scratch. And so it was quite a tough work, but I have also written a paper about it. You can then also download it from the DeepSec website, and yeah, that contains all information. The bootkit is a rootkit that is stored inside the masterboot record. That means it's loaded at the very first level, directly from the BIOS, and it's basically like an operating system. So it's loaded before the operating system, and then it executes and stores its code into the end of memory and hooks some functions, and then it loads the original operating system, in most cases Windows. And then on sometimes it will get called through interrupts, through hooks, and then it will get from one stage to the next and keeping transforming from real mode to protected mode from different processor modes. And it does then exploiting the design of Windows and of the whole Intel architecture, and loads then a payload, and which demonstrates then that it works. And for the demonstration, there are different payloads currently available and shipped with Stone. One is the remote surveillance software, and another one is the command line privilege escalation, which works just that the controller, the cmd.exe, is escalated to system rights, and when you do a whoami.exe, it will show that it has now system rights and not normal user rights. And the whole thing is that you can go to any computer and you can store up the bootkit on it, and then you can boot, and the bootkit will raise you all rights you want and can do everything it wants, and the operating system has no longer the full control over it. and the bootkit attacks the operating system. And the interesting thing is that it can be made everything operating system independent. So currently there is support for all 32-bit Windows operating systems starting from 2000 up to Windows 7. And we're currently also working for supporting Linux, and partly 64-bit is also attacked, but that's currently under development. As you can see here, the execution flow, it's loaded by the BIOS. The master boot record is the first sector on the hard disk, which is always loaded. And normally it contains just a simple bootloader, which loads the bootloader of Windows. And in our case, it loads the bootkit and then loads the Windows loader. And our attack is only done in memory. That means if you restart your system, everything is vanished. And we do not patch any system file on the hard disk, but only in memory. And this is good against detection, because antiviruses normally do just make detection on hard disk. And if it's in the memory, then it can also hide itself. It can hook, for example, the Windows functions, for example, create file API, or it can hook itself and hook the driver stack and gets all the cores when it wants to read the hard disk. And then when accessing the master boot record, it can just hide itself, the bootkit, by just simply pointing to another place where the original backup is done. And the bootkit itself is quite small. It's just the boot sector, the 500 bytes. And everything is written in assembly language, so it's just a few kilobytes of code. But it can do a lot with that. And here you see a typical Windows startup. That means it starts with the master boot record. And the master boot record is replaced by our stoned bootkit loader, which loads the stoned bootkit into memory and then loads the partition bootloader, which is from Windows. And then it will go through all steps of the Windows startup, starting with the NT loader, and on Vista and Windows 7 it's the boot manager, which starts OS loader and then switches to 32-bit mode, protected mode. And then it will start NTOS kernel, load all boot drivers into memory, the HAL.dll, and initializes the whole system. And these are also the points where the bootkit has to move, because there are different operating system modes, processor modes. So you have to make the transform from 16-bit to 32-bit. And you have to always keep care that you are executed. That means that you have to patch functions of Windows, which are typically the Windows, the initial load file function, which loads all Windows system files, like NTOS kernel. And when you hook that, you get all the cores, and you see all the files that are loaded, and you can then patch them in memory. And you have also to keep care that the hashes are valid, that you hook also the hash functions, or you can recalculate the hash of the PE file, and then Windows won't detect any change. And later you have to keep care that is executed beside the kernel, and you do that by patching NTOS kernel in memory. And there are a lot of tricky things, because you have always just a small amount of memory. For example, when transforming from 16-bit to 32-bit, it's writing itself on the end of the NTOS kernel image, which differs between all operating system versions. So there are small things which are different between every Windows version, and partly also between server specs. For example, between Windows Server 2000 and 2003, Windows Server 2003 and 2003 R2. But basically the signatures for the files, which search for functions to hook and to patch, so it keeps called and undetected, are the same for all Windows versions, because the signatures I'm scanning for are just assembly code instructions, and they don't differ much. Even if the C++ code is moved to another place, the assembly code will be still the same. So the signatures are nearly all the same for all different Windows operating systems from 2000 up to Windows 7. But of course, for supporting 64-bit, there has to be much more done. And the 64-bit architecture has also a lot of changes. Previously, I have stored the whole bootkit into the master boot record, because the first 63 sectors were free. They were not occupied by anything. The first partition always started on 64. But now I have moved that concept because the AV industry, they check only the master boot record, so they read the master boot record and check against signatures. And you can fight against those if you patch a few instructions into the bootloader of Microsoft, which just load the real bootkit from the end of memory and place it into memory and execute it. These are just about 8 instructions, and then you just patch the Microsoft bootloader, you inject instructions, and they can't make a signature out of it because the antivirus companies, they make, for example, a signature about 206, 300 bytes, and here you can't detect those 8 additional bytes. So the bootkit is stored on the end of memory, and previously I've only stored the payload driver file on it, and now I'm using the unpartitioned space at the end to store all the bootkit files, to hide it from the other file systems, which are normally accessible and viewable under Windows. So you need a special driver to read my own file system. I have called it rawfs, which is a very simple file system that stores just my bootkit files. And so no one will ever see those files, and no one other than me or my bootkit will have access to those files. And here you can see the boot record of my bootkit that shows that this binary is loaded into memory. It consists of multiple modules, and each module has something to do. For example, we have the system loader, which just loads everything into system, and we have to provide our own file system drivers and hard disk drivers in the bootkit because Windows is of course not available. And some other function, for example, the crypto module is used for the hibernation file, so we can inject any code into the hibernation file, and when Windows resumes from hibernation, then it will load the modified content into memory, and it does not do any checks. There is just a MD5 checksum, no, a CRC32 checksum, but you can set it to 0 and Windows will then not check it. So it will load the modified hibernation file into memory. And this is also a way how you can bring unsigned code into the kernel. And this issue was reported. However, they have not fixed it and haven't heard that they want to fix it. Currently, I have only developed it as proof of concept. So there was no real attack against it, but however, it's still attackable. And which is also used, the hibernation file is also used for some forensics, because there are, of course, the whole memory content stored. So that's quite interesting for law enforcement agencies. And there had been another talk at Black Hat about the encryption and everything of it. Then we have one module for attacking Windows, which contains then the whole signatures for the files and the functions which preserve and which will accessing the bootkit in the memory and will place it always onto the right place, and just it's always patching the Windows files in memory and attacks them. And for Linux, there's then of course another module, and when the operating system is executed, it will be determined which operating system is now running, and then the module is called. Here we can see the file system I'm using. It's basically very simple. You are just using the unpartitioned space that is on the end of space. Normally they're about 10 megabytes free on every hard disk. Under Windows you can't make the partition over the whole space. They will always stay about 10 megabytes free. And Windows also uses it for its own purposes. And I'm using it to store my files and to hide it from the other operating system. And here the structure is just that you have a simple file table which tells you the position of every file and the position of the next file table part. And the file table contains the MD5 hashes of the names. So I know that for the want a file /bootkit, then we'll search for the hash, and then it tells me the location and the size of it. And this is very interesting when working together with encryption, because, for example, if you encrypt your drive, independent if you encrypt it only the system partition or the whole hard disk, then you will always have the master boot record unencrypted. And you will always know the position of unpartitioned space because the partition table also will not be hidden. So when the whole hard disk is encrypted, you know at the end of space, okay, there's place and there I can store my files. And the master boot record always stays unencrypted. Of course, it contains the decryption software, for example, TrueCrypt, and you can simply overwrite it and place your own software. So when you have a fully encrypted hard drive, you can infect it with the stoned bootkit, and it also works. And to show that example, there's for example Live CD, which is based on Windows PE. That's Windows pre-installation environment. That's a small Windows that runs on a CD, which has only the basic APIs and functionality available, but which is more than enough for our usage. Windows PE is, for example, used for the Windows setup. And you can develop your own process for it, your own graphic user interface. And in our case, we have just the infector, which places the bootkit onto the hard disk and does nothing more, and just starting some other programs, just some diagnostic stuff. And the live CD, and you can just insert the live CD into any computer, boot from it, and then you can infect any computer with it, also if it's encrypted. And of course, you can also place the Windows PE on any flash drive, so you can also use a USB stick. And the thing is created with the Windows installation kit, Windows automated installation kit, which is freely downloadable and freely usable for any purpose. And beside the infector CD, which is, for example, interesting for law enforcement agencies if they have physical access, I've also created a native CD, which does nothing more than placing stoned only into memory, not infecting the hard disk, which is interesting for testing purposes. And for this, there is the L2 bootable CD-ROM specification, which tells just how it has to look, and it loads just the bootkit into memory, and my bootkit will load then the main operating system. And I use this for testing it on my own hardware, because it would be uncool, of course, if the bootkit wouldn't work, and then if the whole PC would hang and I could nothing do. And the Infector CD, for example, also contains the restart program, which takes the backup and writes it back to the master boot record and uninstalls the bootkit. And on displays, I want to ask Michael Laselle to continue. He is the developer of the Trojan, which is on top. I will tell you later about how it works on top, because you have different payloads, and his Trojan is developed independently from my Stone bootkit. It's a normal Windows application, and in my bootkit there exists a simple Excel loader which loads his Trojan into memory and gives it full system rights, and which also hides it from the operating system. It's loaded by me, by Stone. And also the PE format is interpreted and it's relocated, and the import address table is resolved by the Stone bootkit, so the operating system will never get in touch with the file. And so you can also pretty hide it good in front of the operating system, which is also one of the main differences between a rootkit and a bootkit. A bootkit starts from zero, from before the operating system, has its own drivers and does everything itself. And the rootkit uses only system functions and requires also the operating system to boot, and also needs the operating system API. So, please.
First of all, here's our agenda. First, what this is about, and the concept, features, and what kind of plugins it uses. First of all, about the RST. The RST is a tool for monitoring and manipulating computers. Well, I've tried to explain many people what it really is, but it's easier to call it a Trojan. But exactly, and the RST is a toolkit utilizing various technologies to control vast amounts of PCs for the use of administration, surveillance, information gathering, and other uses, well, you probably can think of. So, well, features. it uses different ways of encryption and communication. It uses plugins for nearly everything, so it is very versatile and it can be nearly everything you want. Then authentication, also a nice feature using RSA or DSA. Then it's completely scriptable, means it does not need to maintain a permanent connection to its control server to do things. Then updating. It's able to update itself or just plugins, and also update them without restarting the main executable. Then another concept used in there is code in the wire, which was actually mentioned by someone else before, but I don't remember where I read this. And then also droppers, which I'm going to discuss later. Then the concept. As said, it's completely based on plugins, which are currently simple PE images which are loaded into the main process. Then the imports are resolved and, well, it's run. It utilizes the concept of code in the wire, which I'm, as I said, later going to explain. And, well, it's used for executing code from the cloud. Another cloud service. The next part, I saw this was not gonna making it in the final presentation, but well, it's there. Then developed and tested for the Stone bootkit, which means it's totally compatible with the Stone bootkit and also uses some features which are normally not available to end users of this kit. Then plugins, as I said, plugins for everything. Communication, well, it can communicate with its control server over TCP/IP, normal sockets. Then various peer-to-peer networks or Web 2.0 network services like Twitter and Co. Then plugins for authentication, RSA, DSA, or whatever suits you. Then encryption. Well, I've currently only implemented Shifter Saver 2, which is based on RC4, but it's kind of more secure. Then commands. Well, as I said, you can load PE images into it and just run them, and with this it can make really nearly everything. Then also plugins for other users. Well, the stub is very extensible, which means you can also write plugins for other things like systems management or providing a web interface to the whole thing. So then the communication plugins. Well, they give the possibility to using nearly any medium for communication, as I said, TCP, UDP, or another nice thing are raw IP packets with SYN-ACK requests to transfer data, or using the sequence number, or just putting anything there which looks not suspicious. Then, as mentioned, Twitter and Co, which was seen also with other bots which use these services. Then Pastebin, something like this, can also be used simply for this. Then one-click hosters, also a nice thing. There are many, really many one-click hosters out there, and well, it's not really hard to use them to distribute commands or new updates. Then peer-to-peer networks. Well, it works with DHDs or Overnet, Nutella. Well, whatever you can right plugin for you can use. So command plugins and code in the wire. Well, it can do everything with the plugins. For example, if someone likes it, it could control your coffee machine from remote, or just for system management or collecting data. Then code in the wire. This is actually, the concept is that the code is never ever stored on the disk, but just transferred to the host computer, stored in memory, and then directly executes. Which means it only exists, well, in the wires. So, scripting and droppers. The RST is totally scriptable and uses so-called droppers to submit then the information to specified hosts. Well, it can go. I've currently implemented droppers for HTTP and SMTP, but you can use virtually any protocol you want, and you can write a server for it. Yeah. So, well, yeah. Then, what's going on in the future? Also, planned is support for more platforms like Linux, Mac OS X, all the like BSD systems, then platform-independent plugins. Also nice because means that the stub cares how the stub loads image. It don't have to be PE or ELF or something like this, but it gets executed on any x86 platform or x64 if you if the stub runs on this platform. Then also planned are poly or metamorphic stubs to make it very hard to detect. And yeah.
Thank you. I will continue on this. Of course, the bootkit was not just a new introduction by me. It has existed since many, many years. I think the first time it appeared in history was in 1987 by the original by Stoned. This is also why the name Stoned came there. And Stoned just displayed a message, your PC is now stoned. And it had not done much. It just was spreading itself using the boot sector. So when it's loaded from floppy, for example, when it's executed, booted from floppy, it will store itself in the memory. And then every time a disk write occurs, it will check if the boot sector is infected. And if not, then it will spread itself over the boot sector of the hard disk or floppy drive. So it was quite famous in the past, in the mid-90s. And I've taken the message, your PC is now stoned again, which is then always displayed when booting, and then you know that your computer is stoned. And the very interesting thing on that is that it's operating system independent, because today we have all viruses are normally dependent on Linux, Mac OS X, on Windows, and the original stoned virus was really independent from the operating system, because it just hooked the BIOS, and the operating system calls the BIOS. So independent if Windows was used or if DOS was used, it always infected the floppies and all hard disks. And this was a quite cool thing, but of course today, when using the 32-bit operating systems, that's not easy and not that easily possible anymore. Now we have to, there's not a totally generic way, but you can make a module for Linux and for Windows, and you can keep it quite abstract, so you can do a good job for making virus for both Windows and Linux platforms. And of course, there is already a technique against it. There's a trusted platform module. The trusted platform module stores hashes of every single boot file into a secret storage. and the BIOS sends the hash of the boot sector and of itself to the TPM module. And only if all hashes are valid, then the TPM module will give free the decryption key, and only then it can load all Windows start files. So if you modify the BIOS, if you modify the master boot record, then your computer will abort to start because the TPM won't give free the decryption key, and then you cannot boot anymore. There is, however, a security flaw, because the TPM says when restarting the computer, it should erase the whole memory with 0. However, the TPM, the Trusted Platform module, is just a passive module. It won't modify the memory or check the memory. So it says that specification says the software should erase the memory. And of course, you can always do something against the software. You cannot patch the BIOS because then the hash would be invalid. But what you can do is using the debug registers of the processor to set those breakpoints to the according places. And then you can intercept the calls. You can then intercept when the BIOS will load the boot sector. And then you can say, okay, don't load that boot sector, load another. And you don't have to patch the BIOS, but you can use the debug registers to hook it. And what you have to do is you need 2 signatures. One for finding the code which erases the memory, because you place your bootkit in the memory, on the end of the memory, and then you have to find the code in the BIOS which erases those memory, and you set a breakpoint on it, and then you will just keep those few instructions. And then the second is when it loads the bootloader, you have then moved the bootloader to the backup, and the whole thing is then that you do a restart, so you jump to the initial point of the BIOS, and then it will reset the TPM. Then it wants to overwrite the memory, but the bootkit, the debug breakpoint of the bootkit will say, okay, skip those few instructions. Then it wants to load the boot sector, and the bootkit will say, okay, load another boot sector, the backup. And then the bootkit will be placed in memory, and the BIOS will load the original bootloader of Windows, and it won't detect any change because the hashes are all valid. The BIOS won't be modified. It loads the original bootloader, which is also not modified, and then you can basically inject unsent code, untrusted code, and then the system is compromised. And the TPM should just make the whole system trusted. And so you can install my bootkit on a TPM secured system, also encrypted system, and you can install a Trojan, for example, and it will get full access rights, and there won't be any modifications detected. And so that's it. I have placed here a few references. There are quite good ones available, and I want to thank you for your attention, and I want to thank Michael Sendler for joining here tonight and holding his presentation. Okay, thank you.
Thank you. Questions? I think question concerning that dropper stuff. I can't imagine really useful. It sounds like really far in black hat. So can you comment on that?
Well, droppers are for that reason that the server does not maintain a permanent connection. The RSD just executes what it should do and executes the result back to his drop zone. It literally drops his information at another server.
Bitte nicht dieses Mikro verwenden, ihr habt jeder euer eigenes.
Well, it looks like that, but it depends on how you use it. You want it, for example, to use it by law enforcement agencies. Use it a good way, and the whole project there shows up those how to attack those systems. And of course, you can also do something to secure it. You can use TPM, or you the DPM specification to make it more secure. So it's not only black hat. So.
Any further questions?
My question, you mentioned CD-ROMs and USB sticks. So is there a limitation? Do you always need physical access to actually install it?
No, you can also have the Windows executable in Factor. So a normal executable, which just writes the master record on the disk. However, there are limitations. If there's, for example, an antivirus running, which will protect the master record, then this is a limitation. So if you have physical access, then it's quite better because you can use the boot CD or USB flash drive to start from and infect it. Or you can also take just a hard disk and write and draw on the hard disk. If, for example, booting from the CD is disabled in the file.
Okay, my second question is the microphone actually on? I don't think so. Okay, so I can also speak up. You're fixing the problem. So you mentioned earlier that you need to patch the Windows bootloader for current versions of the Windows. Okay. So you need to fix the bootloader, and you said that your current antivirus solution can detect this if you can understand how this is possible if you cannot detect the changes in the environment.
Well, they can detect the change, however, they can't make a signature out of it because the modification are just the instructions, a few bytes. An antivirus works always with signatures, which have normally to be about 200 bytes long. So those few bytes would be too less to detect. And previously the signature was going through the whole master records for all 63 sectors, but now only a few instructions are injected. So they would make false positives when trying to make a signature of the bootloader.
Okay.
So are there any other questions?
Any more questions?
Thank you for those interesting presentations.
Thank you. You can also ask me then later.
Thank you.